Hi, this is Group 86, and this is our project analysis on possible relationship between outage duration in the US and potential factors. So nowadays, with all kinds of electrical devices we have, our daily life is tightly connected to the electricity. So with small power outage for a few hours, our normal life space can be greatly affected. However, by our research in 2020, on average, a person in the US went through around 8 hours without electricity. This is twice as long as that of 2013. So we can tell that power outage is actually becoming a more serious problem nowadays. So therefore, we want to find out what factors are influencing the power outage in the US. Our exploration is in terms of two aspects: the number of occurrences in the of outage and duration of outage.
So for the hypothesis part, because the thunderstorm or big rains will cut down the power line, so we believe that the severe weather are possibly the most common reason for the power outage. Then for relationship, we think greater electricity consumption and more consumers served in that state cause longer outage event. And we also agree that there is a positive relationship between the land percentage and outage duration. Then for data part, we analyze data of outage in the US from 2000 to 2016. So in the dataset, we include some necessary information. And then in the data cleaning part, we just roll climate related information out because we've already seen previous climate related studies based on this data set. So our goal is to figure out that if there are any other potential factors. Yeah, so that is the reason. And then after cleaning data, we found out that the box plot of the outage duration contains extreme outliers. Like you can see on the first image below. So we figured out those outliers, then we check the distribution, and we see that it's highly rescue. So we apply the log10 transformation to ensure that the large value won't drop tendency.
Hello, I'd like to talk about the ethics and privacy of our project. We try to make sure we find the best overall consequences of the data. Since we are analyzing the result, we should be responsible for the analyzation data not being biased by thinking thoroughly on all possibilities. Our project data is about the electricity outage, which is the data published by the government agencies. Public supervision is the best way to construct a panopticon structure to restrict the abuse of power. Then government published data has basically no privacy based on government's function and responsibility.
For our exploratory data analysis, we did analysis for both single variable and multivariables. First, we defined outage duration as y, and each numeric factors we picked as x. So for analysis, we use most of functions from Seaborn. We use box plot to clean the outliers. We use this plot to draw histogram to check distribution of data before and after data cleaning. We use lamp plot to draw scalar plot to see linear correlation relationship between y and x. We also try to see some possible polynomial relationship between y and x. And finally, we use OLS linear model to give detailed relationship analysis of linear regressions between y and x. And for OLS linear models, we check these three values. First, condition numbers to check for collinearity proper. Second, p-values. And first, R-square values to check the level of correlations. And for multivariables, for OLX linear models, we did two steps. First, we put all variables we picked together in OLS. Then we draw another OLS to see all variables we found that have negative or positive population relationship. With y and x, we found one single variable analysis before to see how multivariable result will be.
Hello, so let's move on to the limitation part. Since our data is retrieved from the government dataset, where the government might intentionally looking for outage data, not including too many perspectives of data that might be relatable as well. In the future, we may take a further step to include the geospatial scale information into the analysis. Fixed topographical variables like altitude and latitude might also count, as they might cause the severe weather and then contributing to longer outage duration found in the area. In addition, climate data like temperature, wind, humidity, etc. of each day is a huge dataset that can also pinpointing down to the specific time of the day, which can possibly link with the time when people encounter outage. So jump to the conclusion, because the phenomenon that all numerical factors have no correlation with outage duration is hard to convince us, we also conduct the OLS regression with combined factors to ensure we didn't miss the possibility that there might be some factors action together to affect the outage duration. We tried land and water area, prices, all factors that may have a negative relationship with a small R-square value, and all factors together. As a result, we didn't see a relationship between the outage duration time and those combined factors. Thus, we reject our original second hypothesis, the electricity consumption, consumers served in that state. The land percentage don't have any correlation with outage duration, but it seems that the number of outage occurrence has a negative correlation with outage duration time. So that's a presentation of our group 86. Thank you.